This video is about isotopes. Now, we've talked a lot about elements so far this chapter. The way we define an isotope is that it is an element that has the same number of protons. Because remember, the number of protons is what determines which element we're looking at. But it has a different number of neutrons. So if we think back about the information that's shown to us on the periodic table, this won't change the atomic number, because remember, if we change the atomic number, that changes the element, because that number is what's telling us the number of protons. It will change the atomic mass, though. This is why the atomic mass is never a whole number. It's always some kind of a decimal, and it's because it's an average, and it's making up for these different isotopes that are present out there for some of the different elements. We'll talk for a second about one of the most famous isotopes. It has to do with carbon. Now, if we take a look at this picture, I'm going to actually switch up the color on the lightsaber a little bit. We're going with the Yoda green lightsaber for this one. Typically, carbon is carbon-12. So carbon usually has 6 protons, we can count them up there in our diagram, and then 6 neutrons. There are 2 major isotopes of carbon. The first one is carbon-13. You can see this one is also stable. If you remember from the atoms activity we did in class, some elements become unstable if they have the incorrect number of neutrons. That was one of the things you could use as a clue when you were building those elements in class, or when you were building the particular atoms for those elements in class. Carbon-14 happens to be one of the unstable versions of carbon. And it says over here that it's radioactive. What this will actually end up doing is it will give off one of those neutrons through what's called beta decay. And over time, we can actually use the amount of carbon-14 in something that's been preserved to identify how old it is. So for example, when scientists dig up remains of a fossilized creature, they can use carbon dating to figure out about how old that creature is, because carbon decays from carbon-14 into carbon-13 at a predictable rate. And the assumption there is that all living things have pretty much the same ratio of normal carbon and then carbon-14 in their systems. So when things die, this carbon-14 eventually ends up giving off a neutron through beta decay, becoming carbon-13. And you can go through and measure the ratio of normal carbon to the radioactive version of carbon, and then you can predict how old something is. So it's not like this just applies to carbon, but I wanted to highlight this one as the example because it's probably the most commonly referred to isotope. But basically anything on the periodic table has different isotopes. Some of them, like in the case of hydrogen, they have different names depending on which isotope it is. We're not going to get into those kinds of details. You'll probably do more of that next year in chemistry. The main thing that I'm concerned about you knowing is just our standard definition here. So you've got an element with the same number of protons as normal, as what we normally see on the periodic table, but a different number of neutrons. So take a moment to answer the questions after this video. Since this one's short and kind of simple, there are less questions to go along with it. And then tomorrow in class we'll work on an activity for isotopes. Thank you.